So, this is your professor, Adara Omar Fisher, continuing on with our chapter in bone. We're going to continue now with section 6.3, which is bone formation. So, how do we make bone essentially? And we've already discussed a little bit about the osteoclast and osteoblasts and osteocytes, some of the bone cells. We know that there's the inorganic matrix, which is the minerals, and the organic matrix, which is collagen and other elements as well. So now we're going to talk about the process of making bone, and then after that's going to go into like bone growth. All right, so process is called ossification. Ossification, process of bone formation. Ossification, you can also find the term osteogenesis. As I have listed on the slide here, it begins in the embryonic period. We all know that we grow, from the time that the sperm fertilizes the egg, that egg starts to go through the process of mitosis and starts to develop into the formation of, a little baby, which is then, 9 to 10 months later is born and continues to grow until it goes through puberty and becomes an adult. And then pretty much after that point, we stop with our major growth. Obviously, things like your hair may or may not grow, continue to grow, your fingernails, things like that. But as far as getting taller, bones getting longer, that process pretty much stops, right? So keep that in the back of your mind as we talk about this process of ossification, this process of bone growth. So continues through childhood, with most bones completing the process by age 7, most bones, right? Remember, you have 206 bones. You may say by 7, no. Well, I kept growing after 7. Yes, we said most bones. There's a lot of bones that continue. There are bones that continue to keep growing, right? There's 2 different mechanisms. First bone is formed as immature primary woven bone, irregularly arranged collagen bundles, osteocytes, sparse inorganic matrix. So your first bone is not as organized, but then that primary bone is broken down by your osteoclast. See that there? Osteoclast, break down bone and replace it with secondary or lamellar bone and more inorganic matrix. That's your hydroxyapatite, and so much stronger. Okay, so your first bone, immature, not as well organized. That bone is broken down, replaced, broken down by your osteoclast and replaced. And your secondary bone is much stronger. So bones are formed by intramembranous ossification, which is built on top of a model. And bones are also formed by endochondral ossification. Notice they both have ossification, both have, that's the process of bone forming. Endochondral ossification are built on a model of hyaline cartilage. So the intramembranous are built on more of a connective tissue model, and the endochondral ossification is built on a hyaline cartilage model. Okay, so just 2 different processes by which bones can be formed. All right, so your intramembranous, right? So that's the one built on membrane of embryonic connective tissue. Connective tissue is used as connective tissue as the model to build the bone. That's for many of your flat bones, right? So during fetal development. All right, so just the slide that talks about that. So your primary bone in that method of development, formed within the mesenchymal membrane, composed of embryonic connective tissue, richly supplied with blood, populated with mesenchymal cells. Middle layer of spongy bone ossifies before outer compact bone layers begins from primary ossification center. So it kind of ossifies from the inside out, right? But remember that the intramembranous ossification, the bone is built on a model of your embryonic connective tissue. Okay, then we also have the endochondral, which is the bone development for all bones below the head except for the clavicles. Begins also in the fetal stage of development, and that's built on, as I said earlier, built on a model of the hyaline cartilage. So it sort of starts off as a cartilage model, and then we build on top of that and build new bone. And that's the many bones in that process complete by age 7. It's very important to sort of throw this slide in. It's not really any great place to really throw this slide in. We could have talked about this when we were talking about osteoclast and osteoblast, but osteoporosis, which is the most common bone disease in the United States, is basically bones become weak and brittle. They become more porous. Okay, so if you see in this slide, you see healthy bone. This is in the vertebrae. It naturally has some holes in it. It is naturally has some holes or sinuses in it, some pores in it. But if you look over here at osteoporotic bone in the vertebrae, obviously, if your vertebrae breaks, that would be your back breaking. So you notice this osteoporotic bone. So this bone is suffering from osteoporosis. Notice it has sort of the same, sort of similar features, has the bigger holes, similar features, but also has a lot of these little holes in it along the way. All right, so it has more pores and it's supposed to have, and that's going to weaken the bone and make it not able to do its primary function, which is to support and give a support and structure, right? So it would allow the bone to break, and then you could have many problems. Obviously, if your back breaks, your hip breaks, things like that, cause all types of issues, right? So that's osteoporosis. So you have more pores, which are basically holes in your bone, right? Osteo, bone, pore, holes in your bone. And it could be caused by lack of calcium or vitamin D. Remember, vitamin D helps your body with absorbing the calcium. Females are more predisposed to it than males. Exercise is something that's very important. When we exercise, our muscles pull on our bones, and that stimulus causes our bones, as we're going to see later in this chapter, can cause your bones to want to strengthen. Okay, it gives it stimulus to strengthen. Hormones can also play a role in osteoporosis. Right, it could be diagnosed by, you can do bone density studies to diagnose your osteoporosis. You can prevent it by exercising, by eating better, eating calcium supplements, estrogen replacement therapies, right? So drugs that inhibit osteoclasts, remember the osteoclasts break down bone. So if we were to use a drug to try to help prevent or stop osteoporosis, we would use a drug that would inhibit the osteoclast, or drugs that stimulate the osteoblast, so stimulate more bone building osteoblasts. Okay, so that's all osteoporosis, right? And so that's in the section 6.3, but going right into 6.4, since it's very related, let's go into bone growth, lengthen and width. So long bones lengthen by longitudinal growth. So if I have a long bone, I have two long bones here, radius and ulna. They both have lengthened this way since I was younger, since I was a baby. Lengthen by longitudinal growth involves division of chondrocytes. All right, so that's a new term, kind of a new term for us. We've talked about osteocytes, osteoblasts, osteoclasts, collagen, calcium, phosphorus, all these things related to bone. But we haven't really mentioned chondrocytes. Right, so the lengthening, so long bone becoming longer, involves division of chondrocytes, not the osteocytes or osteoblasts, in the epiphyseal plate. We mentioned this earlier. The epiphyseal plate, which is located right here, located at the end of the diaphysis, the long shaft of the bone. Remember, the end of the bone is called the epiphysis. On the end of the epiphysis is the articular cartilage, which helps us connect to the next bone. All right, so the epiphyseal plate is sort of at the end of the diaphysis. Bone growth takes place at the epiphysis on side closest to the diaphysis. So it sort of grows and sort of pushes itself out, so to speak. Okay. The epiphyseal plate we can break down into different sections. It's a section between the diaphysis and the epiphysis. So between the long shaft of the bone and the end of the bone. And the epiphyseal plate we break it down into 5 different zones. So it's composed of hyaline cartilage. All right, remember we talked about hyaline cartilage previously, endochondral ossification. All right, it's composed of hyaline cartilage that did not ossify. So still talking about the process of ossification, right? 5 different zones of cells, right? So we have a zone of reserve cartilage closest to the epiphysis, zone of proliferation, actively dividing chondrocytes, zone of hypertrophy and maturation, those are mature chondrocytes, zone of calcification, dead chondrocytes, some calcified, and zone of ossification, calcified chondrocytes and osteoblasts. So now we're going into the process of forming new bone. All right, so here's how we break down the epiphyseal plate. Zone of ossification, calcification, hypertrophy, and maturation, zone of proliferation, zone of reserve cartilage, right? So those are those 5 zones. And this is where we have bone lengthening, bone growth by elongation. Right, so each zone of the epiphyseal plate, except the zone of reserve cartilage, is actively involved in longitudinal growth. So this is when you are still growing, okay? Chondrocytes divide into the zone of proliferation, 4 cells ahead of them into next 2 zones. Chondrocytes that reach the zone of hypertrophy and maturation enlarge and stop dividing. Lacunae are large. Chondrocytes that reach the zone of calcification die. They are far from the blood supply, and matrix calcifies. Matrix, right? That's your that's the inorganic matrix. Calcified cartilage is replaced with bone in zone of ossification. So at that point, the osteoblasts invade, calcified cartilage, lay down bone on top, endochondral ossification. Eventually, calcified cartilage and prion bone are reabsorbed by osteoclasts and completely replaced with mature bone. All right, so just showing you this, just the process of how we go from chondrocytes, cartilage basically, to bone. Longitudinal growth continues at the epiphyseal plate as long as mitosis continues in a zone of proliferation. So remember that zone of proliferation, actively dividing chondrocytes in the lacunae, right? This is hyaline cartilage, actively dividing chondrocytes, right? So as long as they're still actively dividing, you can still elongate, you can still lengthen your bone by elongation. Right? So longitudinal growth continues at the epiphyseal plate as long as mitosis continues in zone of proliferation. Mitotic rate slows around ages of 12 to 15. We start our depending on, well, some people a little bit different, but it tends to, we grow faster, and your growth actually starts to slow down. You're still growing, starts to slow down. So your mitotic rate, so the cells, these chondrocytes going through this mitosis, this hyaline cartilage going through this mitosis, starts to slow down around age 12 to 15, but ossification continues. So you're still lengthening your bones. Epiphyseal plates shrink as zone of proliferation is overtaken by zone of calcification and ossification. Eventually, it over, these cells, these cells that are dividing to help lengthen the bone, eventually they get overtaken, they become ossified. And between the ages of 18 and 21, zone of proliferation is completely ossified. Longitudinal growth stops, epiphyseal plate is closed, right? So so you have these cartilage cells, these chondrocytes that divide, and, have eventually, creating new bone, creating cells that then become ossified, and your bone lengthens. But at certain point, the bone ossifies all of that epiphyseal plate. They stop dividing, the mitotic activity, those cells stop dividing, they become completely ossified. And at that point, there's no more hyaline cartilage, there's no more division, mitotic cell division. Those cells completely stop dividing. So you're no more new cartilage for the bone to be developed on. So no more endochondral ossification happening. And at that point, your bones are the length that they're going to be. And that happens between 18 to 21. And that's the point at which we basically stop growing, right? But you can still see this epiphyseal line where it used to be, where this process used to happen. You can still see it in the bone. And that's, it's called the epiphyseal line. Right, so that's just showing you that process once again. So one, you have zone of proliferation, chondrocytes divide. 2, zone of hypertrophy and maturation, enlarge chondrocytes that reach the next zone, large and mature. Once they get to zone 3, they start to become calcified, develop the matrix around them, and then calcified cartilage is replaced with bone in zone 4. So you go from calcified cartilage, hyaline cartilage, chondrocytes, to it gets replaced with, the osteoclasts break it down, replace it with bone, with real bone, and then you have newly formed bone, and your bone gets lengthened that way, all right? You also have what we call bone growth in width. So bones can get longer, but also bones can get wider, right? Which is also very important process, okay? So bone growth, not only in length, but also in width, is called appositional growth. So longer, elongation, width, appositional growth. So osteoblasts, remember those? 3 types of bone cells: osteoblasts, osteocytes, osteoclasts. Remember that these chondrocytes, those are, when we talk about those, don't get those confused with our osteoblast class and osteocytes. The chondrocytes were in regards to cartilage, hyaline cartilage, right? So osteoblasts, in between the periosteum, remember the periosteum on the surface of the bone, provides blood and nerves and things like that. Periosteum and bone surface, in between the periosteum and bone surface, lay down new bone. So the osteoblasts, between the periosteum on the surface of the bone and the actual bone surface, lay down new bone. Oppositional growth does not result in immediate formation of osteons. Instead, circumferential lamellae are formed, right? So not necessarily new osteons, but circumferential lamellae, so we kind of make the bone thicker. as lamellae are added, older, deeper circumferential lamellae are removed and restructured into osteons, right? So we add on new lamellae, and then the bone sort of reorganizes and restructures those into new osteons, right? Bone growth and width may continue after bone growth and length ceases. So your bone growth and length can stops between 18 and 21 when your epiphyseal plate completely calcifies. But things such as bone growth and width can change even as you stop growing in length. Okay, so as like right now, even if you're over 21, your bones can still be growing in width even if they're not growing in length. This depends on different things: hormones, the forces to which your bone is subjected. That could be directly related to exercise. This is why somebody who has osteoporosis, they tell them to do strength training exercises, because if you apply, your muscles pull on your bones. If you apply those forces, you can stimulate the bones to grow in width, right? And sort of strengthen those bones that have been affected by overactive osteoclasts and osteoporosis. Also diet. If you have calcium, your body stores calcium, builds new bone. It doesn't build it in length, it builds it in width. There are some hormones that play roles in bone growth. Okay, so we have multiple factors play a role in how much cell division occurs in the epiphyseal plate and how long the process remains active. Obviously, we know that the nervous system and the endocrine system play a huge role, especially the endocrine system and our growth. All right, so that is going to play an important role in how we grow and develop. And one of the important aspects of our growth and development is the growth of our bones. So one of the main factors affecting bone growth is a group of chemicals called hormones. We are familiar with hormones. Hormones are released by our endocrine system, released by the different glands, our endocrine glands. Right? We have what we call growth hormone, which you should remember from the endocrine chapter. But growth hormone is secreted by the anterior pituitary gland. Remember, hypothalamus controls the anterior pituitary. Secreted by anterior pituitary gland enhances protein synthesis and cell division in nearly all tissues, including bone. Right, so growth hormone can affect your longitudinal growth of bone as well as your appositional growth of bone. So your lengthening and your width, growing in width as well. Increases the rate of cell division of chondrocytes at the epiphyseal plate. So those are your hyaline, that's your cartilage. So those chondrocytes increases the rate. Remember, if those chondrocytes are mitotically active and they're dividing, they eventually become ossified and eventually become new bone, become covered with new bone, right? So growth hormone increases the activity of your osteogenic cells, including activity in your zone of ossification, right? So directly stimulates your osteoblasts, right? So all these things are triggered by your growth hormone. So that whole process of ossification is stimulated by your growth hormone, which is secreted by your anterior pituitary gland, right? So it affects the cell division, your mitosis of your chondrocytes, your osteogenic cells, your zone of ossification, and also your osteoblasts, which help your bones grow in width. Testosterone, which is male sex hormone, which is produced, produced in the testes, also increases your bone width, and increases the rate of mitosis in your epiphyseal plate, right? So that helps you. It helps you. Those chondrocytes have to divide their cells by mitosis to get to get those cells through those zones. And so we need to, and so the testosterone helps that process, increases that rate of mitosis. Therefore, more cells are being created, which will eventually be ossified, which will eventually create new bone. So your bones, so that testosterone helps your bones grow faster, right? That's why men tend to grow a little bit taller than women. And even in females, you do have estrogen, which plays a role, increases the rate of longitudinal bone growth. It can inhibit osteoclast activity. That's another reason why they give some women who are suffering from osteoporosis, they'll give them estrogen because it does inhibit osteoclast activity. But as estrogen spikes in the teens of women, they have a growth spurt, right? And so bone growth is also obviously it's important in women as well as in men, but it also estrogen and testosterone both increase longitudinal bone growth. Okay, so both of those hormones play a role. Growth hormone and in men and women, testosterone primarily in men, estrogen primarily in women, all influence all influence bone growth. And as you see here, it says last line, estrogen accelerates the closure of your epiphyseal plate much faster than testosterone. So men grow longer for a longer period of time than women do, which men tend to be taller than women, right? So just a little fun fact there. And that is the end of our bone growth section.